And now I would like to welcome our keynote speaker, Anoop Kunchukuttan. He is working in Microsoft for last 10 years, and he has done his PhD in IIT Bombay with Professor Pushpak Bhattacharya. Pushpak is also online, going to participate in panel discussion. And he's been expert in machine translation and transliteration. And currently he is a senior AI researcher at Microsoft and a specialist in machine translation, especially in, I would say, the neural machine translation. Now, if we have been checking Bing Translator, there has been a remarkable improvement in quality of the machine translation done by Bing. We have also collaborated with Microsoft Bing in creating English to Urdu. And his research interests are, of course, NLP and multilingual learning for related languages. Anoop is a very interesting, actually, a researcher. He talks about India's different language families, how they are related to each other. And that reminds me of, Ameno, the famous linguist from America who worked for 25 years in the Dravidian languages in Kuppam, and finally concluded that the whole of India looks like a single linguistic area. And he attributed a lot of it to Sanskrit, because of Sanskrit, it appears to be a single linguistic area. So I would hope that Anoop certainly is also working on those lines. And he has also recently released Indo-Wordnet Parallel Corpora. And also he's been working for AI for Bharat India Corpus. He's released that corpus also. And today he's going to speak on the similar topic, NLP and for related languages. So Anoop, I welcome you again and now invite you to deliver your keynote speech. Anoop. Anoop, are you there?
Hello. Yeah. Sorry. Yeah. Thanks. Thanks, Dr. Jha, for the kind introduction and for the kind invitation to present to this audience. And it's nice to see so many people. And this is a new experience to kind of have a conference online. So it's good. And I think some of the things I want to talk about. There's been a nice introduction from you as well as Professor Jagdish. So I'll get started. I'll probably share my screen. I hope everybody can see the presentation.
Very good. Yes, you're on.
Okay, fine. Yeah. So hello everyone. Today I'll talk about some of the things that I have been working on for a long period of time. This is generally to do with how natural language processing for Indian languages is affected by the relatedness between these languages and what role it has to play in being able to build scalable NLP systems for Indian languages. So this is work that I started when I was doing my PhD at IIT Bombay, and work along those lines continue while I work at Microsoft. So these are, and I'll touch upon different aspects of this topic. So to get started, like why are we interested in language relatedness? So as we just heard Professor Jagdish talk, India is unique in terms of the wide usage and diversity of the languages that people speak. So we have a speaker base of more than 1.3 billion speakers who speak a wide variety of languages from 4 major language families, and these are amongst the most widely spoken languages in the world. Even English is widely spoken, and then there are at least 30 languages with more than 1 million speakers. If you look at usage on the internet and digital consumption, this is only increasing over the years, and the projection is that by 2021 we would have around 750 million people consuming content on the internet, of which about 550 would be non-English Indian language content consumers. And so that calls for supporting Indian languages at a very large scale. The scale is in terms of the different kinds of applications that we need to support for for different business use cases and social use cases. So these could be e-commerce, digital payments, digital entertainment, chat, etc. It's an entire gamut of services which are online. Uh, and this calls for support from many different NLP tasks, information extraction and related activities like entity identification, linking, or search, question answering, recommendation. And in the Indian context, we need to basically be able to process multiple languages, and therefore kind of horizontal tasks of handling translation, transliteration, code mixed language, these become very important. Now, given the scale in terms of the number of languages, it's a very challenging task for machine learning solutions. So the paradigm for NLP over the last couple of decades has been to look at machine learning approaches primarily. And here the challenge is that, even if the system has to learn something, it has to learn it from data, and uh, for this, a lot of annotated data is required, which requires linguistic input, or at least a lot of human input is involved. And so it's not cheap, it's not scalable if we have to support a large number of languages. The question is like, how can we scale up to so many languages without while being sort of efficient? So that's in terms of like the ability to scale to a number of languages. When you even have a lot of languages, then there are deployment and maintenance issues. Even if you can, if you have the data to train multiple languages, the point of deploying and maintaining a lot of systems, one system for every language, is also expensive. So we need solutions to sort of address those concerns also. Uh, so broadly, in an ideal situation, what we would want is, I'll take an example from machine translation. A lot of examples I will cover today, maybe from machine translation, because that's one area that I work on. That's also one area that the Indian NLP community has worked on. But many of these examples kind of generalize to other applications also. So what we would want is, okay, so if you have a machine translation system for, say, some language pair, English, Hindi, can you use it? Can you improve that, say, using a Tamil Punjabi model? Kind of scenario like that. Or can we do English Punjabi translation, even if we have seen no data for that? Can we train a single translation model for all language pairs so that it's sort of efficient in terms of deployment and serving real-time needs? What I believe we need is to look at a unified approach towards Indian language NLP, and to be able to answer a few questions. Some of these questions being, can we share a lot of the linguistic resources that have been created by many groups, many researchers across different organizations across the country? Can this sharing of resources also, and sharing of maybe more the deployment artifacts, reduce cost and effort for deployment maintenance? By looking at a diversity of languages, can you build systems that are more generalized? And kind of to answer these three questions, what I would like to talk about today is to see if we can utilize relatedness between Indian languages to sort of answer these questions. Of course, the question is why related? Why not? Why limit yourself to a few languages? Answer these questions in general. Can't we build a model which serves all the languages of the world? That's a daunting task. Languages are very diverse, and I think we are far away from that. But a stepping stone towards that would be to look at least a set of languages that are similar, and where we can exploit and utilize those similarities. So that's the point I would kind of emphasize today. Uh, so let's look at what language relatedness means, particularly in the Indian context. Uh, if you talk about related languages, we can broadly look at two kinds of relatedness. So one is languages being related by their genealogy, by how they have evolved over time. So here, languages share words, grammatical structures on account of having parent-child relationships, and this leads to language families. So Dravidian language family, the Indo-European language family, Turkic are some examples. So the Indo-Aryan branch is a branch of the wider Indo-European language family, and that's spoken mostly in North India, whereas a lot of Indian languages in South India are Dravidian languages. So what I want to point out is that so relatedness does not mean just the same language family, but also contact relationships. So these are relationships that have been established over a long period of time due to contact of languages from different language families, and due to that, a lot of their linguistic properties converging, uh, on account of which linguists classify certain areas with such convergence as what are called linguistic areas. So the Indian subcontinent is widely accepted as one such very rich linguistic areas, having four primary language families. So to use some illustration, so we have Indo-Aryan language. These are some cognates across multiple Indo-Aryan languages. So you can see that a lot of words are similar. Similarly, you'll find many cognates across many Dravidian languages. Not just that, but because India forms a linguistic area, there are a lot of borrowings between Indo-Aryan and Dravidian languages. For instance, a lot of words in Dravidian languages are borrowed from Sanskrit. At the same time, many syntactic features in Indo-Aryan languages like echo words, retroflex sounds are said to have been borrowed from Dravidian languages. So there's a wide convergence between these languages. Aryan languages, Marathi and Hindi, both of them written in the Devanagari script. And you can see that there are a lot of similarities between the same sentence in these two languages. So to point them out, one, you can see that there is a lot of there are a lot of cognates and loanwords that are shared between these languages. So this is lexical similarity. Secondly, many of the suffixes, postpositions have a one-to-one correspondence across these languages, which is sort of a morphological correspondence that we observe across many languages. So while content words tend to have a high degree of lexical similarity, function words and suffixes tend to show this kind of correspondence. Finally, a lot of syntactical, high-level syntactic properties are shared. So these languages share the same basic word order, subject, object, verb, and a lot of properties follow from the basic word order. So we'll talk about that later. Uh, so one thing I would focus on a little bit is to look at one particular similarity, orthographic similarity, which I believe is kind of important in order to sort of be able to leverage all the other similarities. So this is not a similarity of the language, but a similarity in the writing scripts, because a lot of data is today digital, and therefore we are looking at how digital data in textual form can be used. So Indian languages, the major Indian languages use scripts derived from the ancient Brahmi script, and these scripts are orthographically similar, which means that there is a largely overlapping character set. It's only the visual rendering of the characters that differ to a large extent, but the logical characters are the same. The phoneme sets are highly overlapping, and the grapheme to phoneme mapping is consistent. So it's pretty much we speak what we write. So these are big advantages, and this is a very simple and powerful property in order to utilize the relatedness between Indian languages. So I'll illustrate this with a few examples. So the first and very simple thing you can always do is that you can read text in any script, any index script, in some other script that you know of, by simply doing very simple script conversion. So Unicode standard has been very systematic in the way it has designed the code points and the ranges, and therefore it's a simple arithmetic manipulation to move from one character set to another. And therefore you can simply visualize a character in one script in multiple scripts very easily, except for a few exceptions. This is important for developers, and this is where when I started working on machine translation, this was very handy, because now I could easily read some other scripts and read it in a script that I could understand, that was useful for troubleshooting, understanding. So even if you don't understand the language, because there are a lot of underlying similarities, you at least have some help while developing before you can go to some linguistic experts. Even romanization becomes easy with a single rule across all major Indian scripts. So this kind of script similarity helps in transliteration. So transliteration is a task of basically representing uh, a name or a word in some other script while preserving its phonetics. So transliteration data may be limited in different languages, but you can train a joint transliteration model across all these languages by pooling together the data from all these languages. And the simplest way to pool them is to sort of represent them in a common script. So this is a very fundamental trick. So all transfer learning approaches are popular with neural learning methods today, and a good thing to do always is to first represent all the data in a common script so that you have maximal sharing between tasks. So this also allows you to sometimes do zero-shot transliteration. That is transliteration when you have not seen an example from any language. So you may not have seen any example of Telugu English, but with a multilingual system trained on Malayalam, Hindi, Kannada, you may still be able to do a reasonably good job of transliterating between Telugu and English. Similar ideas have been used in the speech community, where the Indian language speech sound label set is a common set of phonemes of Indian languages in their mappings to the graphemes in different Indian languages. And this is again enabled because of the script design. The script is also rich in terms of its ability, its systematic organization, which allows you to featureize every phoneme. So every character is approximately a phoneme, and it can be easily encoded into a feature vector. Now, once you can represent anything as a feature vector, you can sort of compute similarities. So you can compute similarities between characters, between phonemes, between words, etc. And this is useful for many applications, say for transliteration, particularly for unsupervised transliteration, for cognate identification, etc. So that's another use case. The index scripts are also partially syllabic in the sense that the basic organizing unit is what is called the akshara, which is a sequence of consonants followed by a vowel. So it's not a true syllable, but it's still an orthographic syllable, a unit of sound, an approximate unit of sound that's useful for some applications. So for example, if you want to do some transliteration, there is some work which shows from Treya, etc., who show that transliteration at the syllable level works better than transliteration at the character level. I have sort of put together many of these operations, syllabifications, querying script information, getting phonetic properties, script conversion, romanization, etc., into a single package called the Indic NLP library. So you may want to have a look at that. So the library kind of aims to do much broader integration across Indian languages, but in the context of our discussion, like there are a lot of operations to look at script information and do a lot of operations across Indian scripts. The next thing to discuss, so moving on from orthographic similarity, it's important to see how this translates to lexical similarity. So lexical similarity, as we discussed, is that it relates to words having similar form and meaning. So these could be cognates, which are words related through a common etymology. This could also be loan words, for example, between Sanskrit and some Dravidian languages. These could be named entities. They have similar pronunciations. And interestingly, like because there are a lot of shared cultural artifacts, even non-compositional multi-word expressions can be same across languages, and then therefore they are spelled almost the same. And this lexical similarity is one of the most important ways in which sharing can happen across languages. Most of the work today in NLP on transfer learning focuses on utilizing lexical similarity. Now, can we quantify how similar Indian languages are based on their lexical similarity? So one way to do it is to kind of take a parallel corpus and for every sentence, take a character level longest common subsequence ratio for every sentence pair and average it over the sentence. So given that you have a parallel corpus, you can get a reasonably good estimate. So we did this on the ILCI parallel corpus, and we can see that some of these similarity judgments will match with our intuitions of which languages are similar or not. For example, Konkani and Marathi are very similar. You'll see similarities among Dravidian languages, less similarity between Dravidian and Indo-Aryan. So this sort of is a useful metric. We compared this metric on European languages also, where you actually have human judgments of similarity between languages, and there was a good correlation. So we believe that this is a good way to capture similarities across Indian languages. Now, how can we use this lexical similarity? So the first use case is sort of to look at Indian language to Indian language translation. Now, because the words have similar spellings, we can think of doing translation not at the word level, but at smaller units, different kinds of small units, which are smaller than the word, so that even with limited data, we can exploit this limited data and leverage the fact that there are similar pronunciations. So it's almost like doing an operation of transliteration. So this kind of translation is somewhere between translation and transliteration, where you represent the entire data in terms of subword units and learn a translation model. Now, this translation model could be SMT as well as NMT. In both these cases, these kind of subword models have been shown to be useful. So these subword models could be character level, could be syllable level, or in the case of NMT, units like byte pair encoding units, sentence piece, etc. But the moot point being, lexical similarity can be utilized by subword level translation. This can even be extended to pivot scenarios where when you're joining pivot tables. So pivot translation is when you don't have a direct parallel corpus and you translate through a intermediate language corpus. In that case, what you do is combine the two models, and when you're combining the models at the subword level, that's much more effective than combining at the word level when you're working with related languages. Then coming to neural methods, one of the great successes of neural methods have been in transfer learning, where you can take a high resource language and then use use translation models trained on high resource language pairs and fine tune them on lower resource language pairs to improve their translation quality. So for example, we may have a lot of Marathi English corpus, but only a little bit of Gujarati English corpus. Can we still train a good Gujarati English translation system? So the standard way to do is to pool together the data from Marathi and Gujarati and train them at the subword level using byte pair encodings or sentence pieces, etc. This works very well, and we see very good gains. Now, how do we sort of make Marathi and Gujarati representations similar? So the simplest thing to do is, of course, script conversion that we just talked about. That itself is a very good baseline, but we could do further. We may do transliteration so that we can account for some sound changes across languages. We may want to do word by word translation if you have a bilingual dictionary at your disposal. Even better, translate word by word. Maybe you have multiple options for every word, and then rescore the words using a language model. So with any one of these operations, we can convert the Marathi corpus into a pseudo Gujarati corpus, and then you can train a translation system on the joint parallel corpus. So the question is, why is transfer learning effective for related language? I mean, is it not possible to use transfer learning with some other source language, say French? So a lot of study has shown that the representation, so neural networks create internal representations of different inputs. So if you look at representations that are generated by the encoder, the unit that processes the input sequence, and if you look at the representations produced for the same input in different languages, we will see that there is a clear clustering as per the language family or as per language similarity, which means that related languages are much more likely to be useful for transfer language as compared to some other languages. And that's why that makes a very strong use case for why we should look at related languages as a way to improve NLP for a bunch of languages that have partial resources, and as a whole, they can share resources across the entire group. So what I talked about now was, we talked about Indian language to Indian language translation. We talked about Indian language to English translation. Another important scenario is English to Indian language scenario. Now, in this case, it's not clear how to do transfer learning because you have to generate multiple languages. So a fine balance has to be maintained between how much can you share across languages and the ability to generate target languages. So simple trick that people have worked on and works fairly well is to uh, specify in the input which output language has to be generated, and this works fairly well in terms of generating the correct language. This is useful because now you can take a single translation model for multiple languages, but it doesn't necessarily improve the translation quality of the low resource languages. So when it comes to English to Indian language multilingual translation, it's still an open problem as to how we can do this very well. Of course, you can sort of indirectly still get benefits from sharing. So one standard trick in machine translation to improve performance is to incorporate monolingual data through bringing in what are called back translations. These are synthetic translations generated by machine translation models in the reverse direction. So if you incorporate this kind of back translated data using a multilingual model in the other direction, that is Indian languages to English, that can improve the translation systems quite a lot. And as you can see in the results here, it's a good improvement over bilingual back translation also. So I talked about machine translation so far, but all these ideas kind of extend beyond machine translation to many other NLP applications. So one of the revolutions that have happened in in NLP has been the rise of pre-training models. And the idea here is that you can use a lot of corpus and create a language model and use that and fine tune it on different NLP tasks. Now, there are many models available, multilingual BERT, but in terms of the Indian language representation, this is trained on Wikipedia, and Wikipedia for most Indian languages is in the order of tens of millions of words. XMLR is a big model recently trained on a lot of common crawl data, mostly in the range of hundreds of millions of words, but the data is not available. So you are stuck with the models that have been released. So if you want to actually train your own models, what we need is to be able to have access to a lot of monolingual corpus on which experimentation can be done. So a couple of recent efforts. So the Oscar project has actually crawled Common Crawl on a large scale and made available the corpus. So this is today available for researchers, especially Indian researchers, to pick up and experiment with. Recently, we have worked on kind of building news crawls for about 10 Indian languages, and this data will also be available soon. The embeddings are already available. What is also important is that English is an important use case. So when we kind of train joint multilingual pre-trained models, English also has to be accounted for, and the English content should come from Indian content, so that domain mismatches are not a problem. It is well known that many translation methods, especially unsupervised translation methods, don't work well when you are doing unsupervised, when you are working with very different domains. Hence, uh, this is important. We also need evaluation tasks. There are very few evaluation tasks today for Indian languages, and that's something that needs a lot of effort, so that these representations that are built can be benchmarked on a wide variety of languages, on a wide variety of tasks, something like what Glue does for English. Finally, I'll briefly go over what syntactic similarity means and how it is used. So syntactic similarity, briefly, most Indian languages share the basic word order, and that is a very strong implicit advantage, because word order is important for language modeling, machine translation. A lot of work has gone into how to get it right. So when you have that for free, it's a big advantage. And this has been used by a lot of systems in the past. For example, the Angla Bharati translation system used a common English parser to sort of generate pseudo targets for Indian languages for rule-based empty systems. When it comes to statistical machine translation, again, For phrase-based systems, we could write the same source-side preordering rules across all Indian languages, and that would work perfectly well. So that saves a lot of effort. We don't have to repeat the same effort for every Indian language. The same advantages are seen when we look at low resource NMT. We can still use these kind of pre-ordering rules across Indian languages and see benefits. Finally, when it comes to Indian language translation, you get something for free, right? Because between two Indian languages, the word order is the same. So what you gain is in terms of making the decoder much simpler, having to do very simpler search, and which improves decoding speed. So rule-based systems, SMT systems, NMT systems have all kind of used this idea for related language translation. Finally, an important point that I wanted to point out is that language relatedness can be successfully utilized not just between genetically related languages, but also between contact related languages. So these are some examples of different kinds of translations. So the first is phrase-based SMT. The one on the right side is where you have NMT to address syntactic divergence using reordering rules. And the last one is NMT, where Tamil English system is fine-tuned on Hindi English NMT model, and you can still see improvements. So to summarize, what I hope to convey through this is that given the scale and scale of challenges to develop NLP technologies for a wide number of languages, utilizing language similarity is very important. And a good starting point is to look at the orthographic similarity of different Indian languages. Contact as well as genetic relationship is important in the context of Indian languages. And in modern times, we need to kind of build multilingual pre-trained models on large corpora for NLU and natural language generation tasks. Finally, we need to keep in mind that we need to be able to develop models that are efficient at training and inference. And we can see if we can make assumptions about language relatedness and speed up training and inference. So thanks. And if there are any questions, I'd be happy to take them if we have time.
Thank you so much, Anoop, for beautifully presenting the relatedness factor, in technology development for Indian languages. Though on paper, we are 4 distinct language families, but as you pointed out, there are genealogical similarities and similarities due to contact and influences, all at the levels of orthography, sound system, morphology, syntax, and in general, language behavior of people also are kind of becoming similar in a sense.
Yeah.
So, and you also pointed out how we can successfully exploit, this language relatedness in creating language technology for low resource languages besides Hindi and Telugu. All other languages could be considered safely as resource poor languages. If you don't have resources, it's very difficult to build technology. And it takes a long way to actually train community, have languages. We had a time actually creating a source for 17 Indian languages in LCI Corpora. And happy to note that you were able to use LCI Corpora for bringing out the similarity index. And you also pointed out how the NMT can help in creating low resource languages and machine translation. In particular, you mentioned English to Indian languages, Indian languages, and Indian languages to English, the reverse machine translation. So thank you so much for bringing out such a useful, presentation.